Okay, so speaking to increase, decrease. So looking at, and this is not the question I asked, but looking at this first one. So this is increase because it's going up from left to right. Then it's decrease. Then it's increase. So that alone lets you know that this is going to be a cubic function at the very minimum. Obviously, we don't. If we assume that the only thing happening is happening within our viewable window, then it's going to be cubic because it's 1, 2, 3. So that means there should be 3 roots. They could be real, they could be imaginary. In this case, we're looking at just the real roots, and that would be this guy, zeros, x-intercepts, solutions. So our roots would be -3, +1, +4. Solutions, zeros, x-intercepts. When I say roots, all of that is interchangeable, which means your factors would be x plus 3, x minus 1, x minus 4. All of these cross through the x-axis. They don't bounce, like speaking to this guy that bounces. It doesn't like just touch and run. So that means they're all multiplicity of 1. So if it asks for it in factored form, as this question did, your function is now written, unless it gets more detailed with like things that it wants to make sure that you incorporate. Typically, from most of the EOC release questions, the questions I've seen so far, if you're that far, you're good. You could obviously type this in Desmos and see if it matches as well. I'm trying to think of other things. Positive and negative, which I believe was on today, or it was yesterday's work. So positive is everything this way in the graph. Negative is everything below the y-axis. I'm sorry, x-axis. So positive is above, negative is below. Increasing and decreasing is the actual direction, like those original purple arrows that I drew. And the biggest thing that I've watched most Math 3 students make the error in is in positive, negative, increase, and decrease. They're mini domains. And I say the word domains, that matters very, very much because you're only using x values. And a lot of people want to start talking about that 20 because it looks like it's going up to 20 and then it's going to come down, which it does. But you're cutting your graph into little chunks with domains when you're talking about increase, decrease, increase again. And so what would really matter, and this one is not set up well to answer this question, but would be, where does it turn here? Where does it turn here? So you're really only looking at the x-axis for positive, negative, and then increasing and decreasing. So like this graph is positive from -3 to +1, and then again from 4 to positive infinity. It's negative from negative infinity because we're assuming this goes on indefinitely, from negative infinity until it hits -3, because now it's above that line. Then from 1, it's below the x-axis, to 4. So from 1 to 4, it's negative, along with negative infinity to -3. And I'm saying that really fast because I was trying to get a lot of vocabulary in a little bit. I haven't figured out how to make any of that easier. Like I said, my biggest call out that I've found that has been a trend is that you look at your y. And the y's don't matter except for max, min, and maybe y-intercept. Other than that, you're really looking in your x values. Obviously, range, if it starts discussing range. In this case, there's an arrow pointing up and an arrow pointing down, though. So your range is going to be all real numbers because it's going in both directions forever. And then the second one, so your zeros would be -2, +1, 3. So -2, +1, 3. You can go ahead and write your factors or get them started. So it's the opposite. And I'm cheating a little bit. Instead of writing x equals 3, move it over. If you do end up with a fraction or imaginaries or anything of that nature, you do really need to set it x equals and then solve it and get it equal to 0, I guess. No, solve it. Get it equal to 0. It's easier with the constant numbers, real numbers in this way, just to know that it's the opposite of whatever it was for a lot of students. But this is not correct because these two did cross, so they're perfect with their multiplicity of 1, but that's a bounce, so this is going to be a multiplicity of 2, which just means it happens twice. And I'll call out that x plus 2 to the second power doesn't mean x squared plus 4. It means x plus 2 twice. So this should be a 1, 2, 3, 4 to the fourth power function when it's done. And if we're reading from left to right, it went decrease, that's 1, increase 2, decrease 3, increase 4. So that also lets you know that if you'd stopped without talking about multiplicity on that x plus 2, the 3 would have given you a cubic function, and this is not a cubic function. There's 4 directional changes, so it needs to go to the 4th power. So hopefully we'll drill it in that bump, when it hits it and runs, it's going to be to the 2nd power. Looking at our next one, we have a -2, -1, +1. I don't know if you think it's weird, but there's some weird stuff going over here, +1. So our roots would be -2, -1, +1. X plus 2, x plus 1, x minus 1. Now, the only one that just went flying through the x-axis like it was a finish line at a race is -1. So that x plus 1 is going to be to the power of 1 or no exponent necessary. So it's a multiplicity of 1. The -2 is a bounce again. So that's going to be squared because that's what bounces are. Bounces are even. And more times than not, you're going to see 1, 2, a couple to the 3rd power, 3rd multiplicity. If you see it in a picture, and maybe a 4, maybe a 4. But when it comes in flat lines a little bit before it runs through, so hopefully in comparison to -1 and +1, you see that it spent some time on the x-axis before it actually blew through it. That's going to be to the 3rd power. It's a very flat cubic function. So another way again to check this, increase is 1, decrease is 2, increase is 3, decrease is 1, 2, 3, 4, sorry. And then flat line for a second is 5, and then decrease is 6. 1, 2, 3, 4, 5, 6. So this would be a 6th power polynomial, which matters to your multiplicity. And I haven't seen a lot of the release questions where you're actually doing this from a graph. The release question actually has it written out more like the question below it, like this. But if you can understand the graph, then again, you can use Desmos to help you differentiate between answers, check if your answer is way off, or hopefully that is way right. So x to the negative, we have a -5. When it says x equals, we have a -5, -1, +2, +4. And it says x equals, these aren't the factors, so it's perfect. That would be your x plus 5, x plus 1 when we're looking at factors, x minus 2, and then x minus 4. Because again, you're moving that whole number over to the side of x and setting it equals 0 for multiplicity. Now, we are not going to multiply this bad boy out because we got lots to do. This will be 1, 2, 3, 4, 5, 6, 7, 8 powers when we're done with this. So that'll be a lot of multiplication. A lot. And hopefully the multiplication part is not a problem. If it is, I just need somebody to holler and let me know, and I will make sure to assign more practice with that. To be able to sketch it. So given zeros, corresponding multiplicities. So at the -5, we have, it's going to bounce at -5. It's going to cross through -1. And they didn't give us any information as far as what's happening on either side, other than that it's a multiplicity of 8, which means wherever it starts, if it starts going up, then it's going to end on the right-hand side going up as well, because it's an even exponent. An even exponent means same. So on the right-hand side, if it's going up, left-hand side is going to go up as well. If it was going down, and you can, in this case, again, not enough information for it to really tell you, but we know at the -5, we'll just say we'll stay positive. It's going to bounce, hit and come through, and then -1, it's going to cross. At 2, it's going to sort of hit and flatline, and then go back up. And then at 4, it's going to bounce again, because it's a multiplicity of 2, so it doesn't cross through. Now, again, you're not going to ever have to really actually sketch these, but there are some things that you should be able to visually associate with all of that information and what it should look like a little bit. You won't actually have to grab a pencil and draw it. It's more like, would you be able to notice that 4 is a multiplicity of 2? -5 is a multiplicity of 2. Does it look like a bump? Does it cross through? Probably the idea that you have an 8 exponent being even, that either side is going to be going in the same direction. I just chose positive. It could have been both negative, and we could have flipped the whole graph over. Remainder theorem. So the fun part about remainder theorem, I think, from students who have discussed with me their issues, it is so easy that you mess it up. Or you try to avoid all the rest of the math we learned because you think this is so easy, and then you can't answer the question appropriately. So the remainder theorem strictly answers the question, what is the remainder? That's it. Or find the remainder. Is it a factor or is it a solution? That's it. It is not solve. It would have to ask, find the remainder. What is the remainder? Is this a factor? Is this a solution? In this case, we have a factor. The remainder is just looking for the end number. This is also the same thing that you would answer with long division or synthetic division, but without doing the division part. You're going to take your x plus 1, because that's a factor, set it equal to 0 and solve. So this question would answer, is x plus 1 a factor? Is negative 1 a solution? Or again, find the remainder like it said. So you're going to take your numbers, and we are just going to plug in that negative 1 that we just solved for. Another big misconception is people take the positive 1 and plug it in there. But I feel like that's for people who just aren't trying to pay attention to what you have to do. Obviously, you can't just take a factor and plug it in there. You have to use the solution. So a negative 1 cubed is going to give you a negative 1 still, because negative 1 times a negative 1 is positive, times a negative 1 would give you that negative. Other big call out on like these, they should be great. Use your parentheses. Make sure you're using, especially if you happen to pick up a TI 83 or 84 to do it. In Delta, they're a little more, Desmos, they're a little more student-friendly in communication. Like the parentheses aren't always as detrimental, but if you don't practice doing it, one day you'll pick up a T84 and then you'll miss a question that should be super easy because you don't have the habit. I would just habitually always use parentheses when you're raising to a power, especially in the case when they're negatives, because if you don't use the parentheses, it gives you the wrong answer, and bless your heart, you absolutely believe it. So 4 times a negative 1 is going to give me a negative 4. Negative 1 times a negative 1 gives me a positive 1. So negative 3 times a positive 1 is 3. 2 times a negative 1 is negative 2. And then minus 4. And obviously, you can put this in your calculator straight through the line as long as you're using your parentheses correctly. You don't have to do like bits and pieces like I'm doing. But we have 4, 5, 6, 7, 8, 9 plus 4. So it's a negative 13. Is the remainder. So since there is a remainder, negative 1 is not a solution. X plus 1 is not a factor. And then to the question that's typed on the page, the remainder is negative 13. And that is literally it for the most surface value of remainder theorem. That is all you have to do. It's a matter of making sure you don't get too comfortable, blink, put in the wrong number. There's no real like overthinking when it comes to just basic remainder theorem. The second one is much more EOC-like in the release question for remainder theorem that we've seen. So biggest call out, and we don't always pay attention, but hopefully a red flag goes off when you see two variables. K and X is a problem. That means you can't come out with an answer. If there's two variables in an equation, whether it be Y, it doesn't matter what letter it is. If you have two variables, you can't come out with an answer without solving or like undoing one of them with a number. So in this case, it's saying it's divided by X plus 2, which is great, except we know we can't do anything with X plus 2, so we have to solve it. And by solve, I mean set equal to 0. So X is going to be negative 2. Now that I know that X is negative 2, I'm down to one variable because all those X's are going to turn into negative 2. And the remainder is 26. Is the same thing as equals to. And now what we're solving for is K. And I'm going to write it in another color so we don't lose it. So K is who we're solving for. We're plugging in the negative 2 in the place of X. And again, if you look at it now, you only have that one variable, so we can solve it. I have found that a lot of students get excited and you try not to write things out because we've gotten so calculator addicted. And again, you make some mistakes in places like this because you'll move things to the wrong side. All of this is on the left side. And we're eventually going to have to get the K by itself and move the answer to the other side, away from it. Negative 2 to the third power means negative 2 times negative 2 times negative 2. Negative and negative gives me a positive. times that negative again. And that's going to be 2 times 2 is 4 times 2 is going to give me a negative 8. Plus, I'm going to turn this into 4k because negative 2 times negative 2 is positive 4. It doesn't matter if the 4 is on the front or the back because 4k is multiplication. So plus 8 plus 2 equals 26. Now, negative 8 plus 8, those basically undo each other. So we have 4k plus 2 equals 26. Hear me out. Trust me. We don't write this out, and then we end up mixing up our positives and our negatives. So like in this case, maybe somebody would write 28 divided by 4, and then they'd answer it. Or whatever wild, mad math stuff we can do without writing when we avoid writing. I know everybody's like, I can do it in my head. I can do it in my head. And that's great, except at the end of the day, there's a lot going on in your head. And that means you got like a 50-50 shot that you don't get distracted and mess up. And we divide by 4 because 4k again is 4 times k. And the division is the inverse. And so k is going to equal 6. Now, you could also plug that 6 back in, plug in your negative 2, and when you've solved it all the way across, it should give you that positive 26. You could, I'm trying to think of all the ways you could check it. If you tie that, I think that's it. That's all I got. Yes. If you could get through your k, you could type it in without the negative 2's in it as if it was just a cubic function. Put the whole thing in parentheses, divide by x plus 2, so that would be your one equation. And then the second equation would be y equals 26, and you would find their intersection, and it should be correct at a negative 2. So when x is negative 2, y will be 26 if k is 6 is correct for this function. Hopefully that made sense. Those dots aren't connecting as fast in my head as I'd like them to. So hopefully when I said it out loud, it makes more sense to you guys. So another one, exact same style. Well, let me get down there. There's extra variables in the other one. So again, problem as soon as you see 2 variables is divided by x minus 1. Next problem is we don't want a factor. We need a number for remainder theorem. So x is going to be a positive 1, and remainder is 2. You're going to plug the positive 1 in for x, set it all up. K is staying k. We don't know what that is. We're plugging in for x minus 1, and it says is 2. So we're going to put plus 1, plus 1, plus 1, and by plus meaning positive, and then we're going to solve this bad boy. So that's going to be 1 to the 3rd power, which is going to give us 1, and 2 times 1 is 2. And I overwrite to make sure I don't make mistakes, minor mistakes with our plus minuses. So 1 squared is 1 times the negative 3 is going to give you a negative 3. K times 1 is just 1k or k. Then minus 1 equals 2. You're solving for k. So we're going to clean up around it first. 2 minus 3 is going to be a negative 1 with another negative 1. So that's 1k minus 2 equals 2. And this would be the perfect one where we would get our positive negatives mixed up if you don't write it all the way through, because you guys like to slam things together. And 50-50 shot with positive negative if we keep it correct. So that negative 2 is going to move over, or minus 2 is going to come over as a positive 2. So k is going to equal 4. And that's saying if that k value is a 4, then when x is positive 1, y should be a positive 2. And so again, you could plug it in Desmos. Well, we said k is 4, 4x minus 1, all divided by x minus 1. So y equals, and then your second will be y equals 2. And then you're looking for your intersection, and that should be at x equals 1. So where this line, this horizontal line would cross this polynomial should be at 1, 2. if k is indeed 4, and we did it correctly. Now, I have not seen a release one of these like this, but I love this question. This just seems so state test-like to me. If both ax cubed, and hopefully already you picked up there's two variables, so that's a problem, and x squared minus ax plus 4 leave the same remainder when divided by x minus 2, find a. Now, if they both have the same remainder, we can say y equals ax cubed. If I'm trying to pull it back to like another lesson you've done in another math class, y equals x squared minus ax plus 4. So when x is equal to a positive 2, these guys are going to have the same output. So whatever this output is, y is the same thing as y, so we can set them equal to each other. So a, and we're going to use our x that we know, that x2, because our first equation should be the same as the second when we use x as 2, when divided by 2. And I think when we say when divided by 2, it's x minus 2, people start getting confused. But that just means that that 2 can go into this equation as the x value. And if they have the same remainder, then they have the same output as 2 being your input. And then we're going to solve again. So a little messy, but 2 to the third power, 2 times 2 is 4, times 2 is 8. So that's going to be a. I'll put the 8 in the front because we typically like our number, our coefficient attached to our variable to the left side. 2 squared is 4 times 2 is going to give me 8. Minus 3 equals 2 squared is 4. Minus a times 2, so it's getting negative 2a. Be careful moving the 2 to the front that you don't make it a positive, because that looks like a positive 2. But this is a negative 1a times 2, which would make it a negative 2a. And then plus 4. And again, we're solving for a, so we're going to work on getting our variable on one side, our constants on the other side. I'm going to work towards a positive variable, so plus 2, plus 2. Also, I highly recommend like cleaning this side up before you start moving things. And this is going to be 8, because otherwise if you move each individual one, it leaves you more room to slide a number wrong, positive, negative wise. And if you're doing it and talking to someone about it, like if I ask you, typically you're good. By yourself in your head, we start making some mistakes there. So I'm going to add that 2a to the 8a, which is going to give me 10a on this side. So plus 5 equals, these are gone, 8, because I combined my two positive 4s. 10a's over here. We're going to subtract 5 from both sides to get it away from the variable. So we have 10a equals, and then 8 minus 5 is going to give me 3. And divide by 10, 10, a equals 3/10. That looks terrible. And I didn't get an answer key, so I'm not sure. If you see where I made a major, like, silly mistake, it can happen. 2 times 2 is 4, 4 times 2 is 8, minus 3. Or like I said, no, this is very ESC-like, so it is likely just an ugly answer. But in theory, unless I made, like I said, a silly algebraic mistake, we should be good at 3/10 as the answer. And we have another one. Hopefully it doesn't give us a nasty fraction. So it's the same thing, just another large, ugly polynomial with double variables, polynomial x and a. They leave the same remainder when divided by x minus 3. So we're not going to use the minus 3. We're going to use x as a positive 3, and we want to find a. So when x is 3, they should have the same output or remainder. So when x is 3, these graphs will be touching y at a certain number, which is what the remainder means. So we should be able to solve them again the same way. Oops, and I didn't mean to write that 3 part there, the x there, I'm sorry. I want to turn the x into a 3. We're setting them equal because when x is 3, they have the same remainder, and that remainder is the output when you solve with your x value of a positive 3 in this case. And then we're going to solve it out. So 3 times 3 is 9, times 3 is going to give me 27. 3 times 3 is 9, times 4. Whew, these are giving us some fun numbers. 36. 3 times 3 is 9, minus 4. 3 cubed again is 27, minus 12, plus a. So clean up on each side first. 9 minus 4 is going to give me 5, so I took care of that. Plus 36 is going to give me 41. Equals whole number 27 minus, and be careful, my A's look, I have a hard time when I don't use X's, keeping my variables separate from my numbers in my head. 27 minus 12 should give us 15. And then we have a positive A. We want to get our A's on one side. Again, I like to work towards wherever the bigger A is to keep it positive. So we're going to subtract an A from each side to get rid of this one. And that's going to give me 26A plus 41 equals 15. We're going to subtract 41 from both sides to move that positive 41 over. And so 15 minus 41, I probably should use my calculator to make sure that's not what's happening with these nasty numbers that we were getting in the other one. So 26A equals a negative 26, because I had 15, but I spent 41, means I owe somebody 26. And in this case, we're going to divide by 26, and A equals a negative 1. And that would be the answer to that question. But again, I guess the takeaway would be your basic remainder, like solving for remainder skill with plugging in your x value, not the factor. So x minus 3, set it equal to 0 and solve. But then also understanding that if they both have the same remainder for that input value, for that x value, then you can set them equal to each other and solve. Only a couple more things I pulled because I feel like we've been doing polynomials for a hot minute, but I will say that statistically, always this is one of the worst quiz grades, and people struggle. And like I said, it is one of the largest percentages of the EOC style questions, or would be with these functions and such things. All right, so x cubed. So speaking to the question earlier, so our leading term would be x cubed. Whoops, and I'm not on the screen at all. Sorry. So that's our term. Leading term is x cubed. Our constant is going to be that minus 8. That is also going to be your y-intercept. The constant is always where the graph touches the y-axis, which is sometimes just helpful. If it was like multiple choice matching graphs, I like to try check down the list without having to do a lot of other work. So this is the leading term. Leading coefficient, in this case, is going to be a positive 1. The degree is a 3. Now, because the leading coefficient is a positive 1, that controls the right side when we're looking like towards end behavior statements, and it's positive, so that means the right's going to go up. Degree controls the left side in relation to whatever the right side decided it was going to do. So if the degree is odd, we're going to flip those D's upside down and we're going to go opposite. So that means the degree, the left side, is going to go down because the right side was going up and the degree is odd. So leading coefficient being positive means the right's up. Degree being odd means it goes down because that's the opposite of going up on the right-hand side. So we'll get to that in a minute. Yep, end behavior's last. So what are the possible combinations of real and imaginary? So this is that conversation again too, that imaginary travels in pairs. So if we have a 3, that means I can have 1 real, 2 imaginary, or I could have 3 real, and that's it. That's the only combinations that will work. So that means that graph will touch the x-axis either 3 times, or it will touch it 1 time, and it'll do its curvy thing up in the air above it or below it, depending on which one. Again, you always have access to Desmos, so you can put it in there to answer some of these questions as well. So like if we were talking about to the right and to the left and which direction it goes in, this is our graph. So again, it's x to the 3rd power, so that's increase, decrease, increase. So there is 3 directional changes. It is touching, and then it's going to go up. So that means it has 1, 2, 3 real, and this is a 2 real because it's a bounce, but it does actually touch. So it did go with the 3 real combination, because it does touch the x-axis at a multiplicity of 2 and a multiplicity of 1. And from there, I don't think we need the graph. We could talk about the zeros are at -2. I'll write these on the corner of my paper. The zeros are -2 and +2. -2 is at a multiplicity of 2. And then we'll come back if we need our picture. So we had a -2, multiplicity of 2 because it bounced, and then +2. So what are the possible factors for this equation? Note their multiplicity. So the factors are not -2, +2. It's x plus 2 at a multiplicity of 2, and then x minus 2 at a multiplicity of 1 because it crossed, because it kept going. It did not turn, bounce, or flatline, or any of the other fun things that it can do. What is the distance between the zeros? There's a release EOC question like that, and it was 3 distinct real zeros, and you needed to figure out which one had the shortest distance was in the release question. But in this case, since it's -2 to +2, that distance is 4 units. So don't think necessarily, well, do think distance can't be negative. So if you happen to flip it the wrong way, or if somehow in your brain what you're doing is jumping on a number line, like if you can think back to like middle school number line that ran around your classroom at the top, like up on the ceiling sometimes, you're counting how many jumps or steps would the frog take to get from -2 to +2. In that case, it would be 4. What is the sum of the zeros? Again, that's making sure you understand that there's a 0 at -2 and a 0 at +2. So -2 plus +2 is going to give me 0. So their sum is going to be 0. In behavior, again, just review throwback. So as x approaches positive, so that means when I look to the right, y is going to go up because the leading coefficient is positive. So it's going to be positive. And then as x approaches -infinity, or as I look to the left of the graph, y is going to go to -infinity or go down because the degree is odd. And odd is opposite of whatever the right-hand side was doing. On that graph, as far as relative max and mins, or relative, and the word just left me, absolute, or absolute max and mins, you would look there. It does continue indefinitely up to the right, so there's not going to be an absolute. It does continue down indefinitely, so there's not going to be an absolute min or max. These would be relative. So there's a relative max at 0, and the max and mins are using your y-axis. So relative max at 0, and then a relative min. And I added this to these questions. So like we can call this -9.5. Typically, if they're going to discuss max and mins, they're going to give you good ones, like actual coordinates. So I guess it would be -9. Yeah, 5 works good. Or you could use the whole decimal if you wanted. And in this case, it's 0. Your solutions, obviously, the cool part about Desmos is you can click all of these to answer lots of questions. Your y-intercept's not really necessary. Other than that, it proves that -8, like I said, is your y-intercept for that function. So we did another one. So x to the 4th power, -x to the 4th power. So again, our leading term, so this is the whole term. Leading coefficient in this case is a -1. Our degree is going to be 4. So -1 means the right is going to go up or down. Since it's a -1, will it go up or down? Yes, perfect. Down, down, down. And then since the degree is 4, that's even. Even means same, same. So that means the left will go up or down as well. So the left will go down as well because even means the same as the prior. So since the prior, the right is negative, then the even degree means the left will also do the same thing. Possible combinations of real and imaginary roots. So I could have 4 real. I could have 2 real and 2 imaginary. And then I could have 4 imaginary, because 4 would just be 2 pairs of imaginary. But I can't pull off 1 real because that leaves me with an odd number from there. So that won't work. There won't be 1 real and there can't be 1 imaginary. So our options would be 4 real, 4 imaginary, or 2 real and 2 imaginary. And again, this one, if you plug it in Desmos, you can see that we have 1, 2, 3 distinct zeros, but this one in the middle has got that multiplicity of 2 because it bounces, and that's increase, decrease, increase, decrease, which again is 4 directional changes as well. You can also see that they're both going down in the picture. It's helpful maybe to know from the leading coefficient and the degree as well. But if not, again, you always have Desmos to reference back. Possible factors of the equation with its multiplicity. So we had that -2, +2, and 0. -2, 0, and +2, and the 0 was a multiplicity of 2. So your factors would be x plus 2, x squared, and then x minus 2. And that squared is because it bumped right there at the origin at 0. As x approaches positive infinity, so that means as I look to the right, that is controlled by your leading coefficient, we're going to look down. Or again, look at the graph in Desmos and you see the right of the graph is pointing down. And then as I look to the left graph is going to also go down because the degree is even, or again, because you are looking at the graph and you can see that both of them are going down. Now, listen, name all possible extrema. So that's just another vocabulary word talking about relative max and relative mins, absolute max, absolute mins. This graph is different than the last one in the fact that it does forever go down, but it does not forever go up. So at the rate of going up, we do have an absolute max, and that absolute max is at 4. We have a relative min at 0, and then an absolute min, there is not one because it's going to continue to go down forever. So relative min at 0, absolute max at 4, and that is all of the extrema for that graph. And we're out of time.